All right, y'all. So we are going to finish the T2L2 notes from class the other day that we didn't finish. I do want to talk real quick about the difference in question number 3 and then question number 4. So whenever we did question number 3 here, we stopped and we just said, okay, we know that we found the x-intercepts. Obviously, there are 2 of them, blah, 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 blah. And so if you think about roles up here, it does say that there is at least one value C on AB such that f prime equals 0. Example number 3 did not ask us to find that value. Okay. So example number 4 does actually say if there is a value, if there is such a C, then let's find it. So we are going to actually have to do that. That's why there's going to be some extra steps in example number 4 than there were in number 3. Okay. All right, so for each function given, is there a value of C on the given interval such that f prime of C equals the value stated? Okay, well, f prime of C equals 0. Okay, first of all, we know that we are talking about a quartic function here, so we are continuous and differentiable everywhere. So that takes care of that aspect. Get my paper set up here how I like to write. All right, and then we're going to check our endpoints. So we're going to check f of negative 3. And that's going to equal 16. And then we're going to check f of 3. And that is also going to equal 16. Okay, so the fact that they're the same, if you go back up here to roles, okay, f of A equals f of B. So f of A equals f of B. Therefore, we do know that roles applies. So now they want us to find that value. So remember, roles says if f of A equals f of B, then there's at least one C on A of B such that f prime of C equals 0. So we've got to find our derivative. And then we're simply going to set our derivative equal to 0. And now you're going to notice in my work, I'm going to change my x's to C just because it says f prime of C. That is the same thing as we were talking about the other day about our w's and x's, just depending on the problem. So they want us to find a value of C. So I'm just going to replace my x's with c's. So instead of factoring out a 4x, I'm going to factor out a 4c here. This will give me 0, and this will give me plus or minus 2. So our C value could be 0 or plus or minus 2. Okay. All right, let's look at the next one. All right, g of x equals, so again, immediately you're going to tell me that we are, it's a cubic function, we are continuous and differentiable everywhere. Now this time, it asks about g prime of c equaling negative 5. So remember, roles is just a specific one of our theorems. Okay, so if you look back up here, we're looking at it being equal to negative 5. So we're going to use MVT. All right, so the first thing we need to find is the derivative. Okay, and then we're going to do our math from there. So remember, we're going up here with MVT. The SOT equals the SOS. So the derivative is on the left, and then f of A minus f of B over A minus B is on the right. So I'm going to put my derivative on the left, again using C. And that's going to equal f of A minus f of B over A minus B. And we're just going to do the math from here. f of negative 2, if I plug in negative 2 into this function up here, that's going to give me negative 40. If I plug in 5, that's going to give me negative 75 over negative 7. Okay, then we're going to move that and set that equal to 0. Okay. And let's see, we can factor here. 3c minus 1 and c minus 5. So then our two numbers are going to be 1/3 and 5. Okay. However, if you look at your interval, okay, our interval, remember, was from negative 2 to 5. So 5 is not a closed interval, it's an open interval. So 5 is thrown out. So our only answer here is 1/3. Okay. And y'all, just for reference here, let me make a, if you notice this is negative 5, it tells us g prime of c should equal negative 5. And that's the same value we got when we did our math. Okay, so the derivative was going to equal, they want us to show that anyhow. Okay, so fortunately it just ended up being that was, we could have jumped down there a little earlier. All right. Y'all know I hate teaching from home. All right, a car traveling on the highway passes mile marker 147, traveling at a speed of 60 miles per hour. 5 minutes later, the car passes mile marker 154, traveling at a speed of 65 miles per hour. Prove that the car must have exceeded the speed limit of 65 miles per hour at some time during the 5 minutes. All right, well, let's just talk about what we know in general. Okay, we know that velocity is your distance over your time. Okay, so in this situation, we traveled from 147 to 154. So that is 7 miles. And then it said 5 minutes later, so in 5 minutes. Okay, well, normally velocity obviously is going to be in miles per hour, which is what our measurement is here. So right now we're in miles per minute. So I'm going to convert minutes to hours. So 5 out of 60 is going to be 1/12, right? So we're at 7 miles in 1/12 of an hour. So keep, change, flip that. Let's do the math. That gives us 84 miles per hour. That is your average velocity over the 5 minutes. Okay, now it was traveling at a speed of 60 miles per hour at 147. Okay, and then 5 minutes later, it was traveling 65 miles per hour. All right, so we know that if we did the average here, that's an average of 84 miles per hour. Now, assuming that the position function is differentiable, because we don't have a function for this. Okay, so assuming the position function is differentiable, MVT does guarantee that the car must have been traveling 84 miles per hour at some point during the 5 miles. Okay, so somewhere over those 5 minutes, sorry, this is so blurry. Somewhere over those 5 minutes, it is guaranteed that the car must have been traveling 84 miles per hour. All right, let's go to the last page. All right, the functions f and g are differentiable for all real numbers. The table shows the values of f and g at various values of x. All right, so we know that f and g are differentiable. So right here, immediately, if it says f and g are differentiable, and you look down here, there's f and g as a composite of each other. Okay, that must mean h is also differentiable. Because all we're doing is subtracting a value from that, therefore that's not going to matter. Okay, so h also has to be differentiable. All right, explain why there must be a value of c such that c is between 1 and 3 and h prime of c equals -2. All right, well, let's see what we've got. We're going to check h of 1 first. So h of 1 would be f of g of 1. All right, and then -3, sorry. Okay, so g of 1 is 2. So that's f of 2. F of 2 is 5, and 5 minus 3 is 2. Now let's check h of 3. So that's f of g of 3. So g of 3 is 3. F of 3 is 1. Okay, so we are going from positive to negative, right? Which we have to cross our x-axis. Therefore, we can say, since h of x is differentiable, and continuous, MVT guarantees a C on the interval 1, 3 such that h prime of C would equal h of 1 minus h of 3 over 1 minus 3. We know h of 1 is 2 minus -2 over -2, which equals -2. So now you've got your value that they asked you to prove. They asked you to prove that h prime of c equals -2. We found h of 1, h of 3, 1 minus 3, and that value does give me -2. All right. Example number 7, last one. The rate at which oil flows out of a pipe in gallons per hour is given by a differentiable function r of time t. The table shows that the rate as measured every 3 hours for 24 hours. All right, estimate the value of r prime of 5 using the correct units of measure. Explain what this value means about r of t. So to find r prime of 5, we're given r. So remember, if we're going to find this, but we don't have everything we need, we're going to use the slope of the secant. So we're going to say r prime of 5 would approximately be the 2 around it. So 5 would be between 3 and 6. So r of 3 minus r of 6 over 3 minus 6. R of 3 giving me 12.4. R of 6 giving me 12.8 divided by -3. All right, so that's going to give me -0.4 divided by 3. Or -3, sorry. I'm going to simplify that down to 2/15 gallons per hour squared. Okay, so there is our value. And just so you know the math on that, so if I had -0.4 divided by -3, right? Negatives cancel, that's fine. So I have 0.4 divided by 3. I'm going to move that point over, making it 4 and add a 0. So 4/30 is 2/15. That's just how I did that without a calculator. All right, so then we know that R prime of 5 represents the rate of change. Of the rate at which oil flows out of the pipe. The rate of flow is increasing because, and y'all should have finished that part of the sentence. Because R prime of 5 is, hit together, greater than 0. Okay, so because we were positive, we knew the rate of change was increasing. All right, letter B. Using correct units of measure, find the average rate of change of R of t from t equals 3 to t equals 18. So we're just doing literally average rate of change. So that's just R of 3 minus R of 18 over 3 minus 18. Numbers from the table. Okay, 0.02 gallons per hour. And then the last one says, is there some time t in between the interval 0 to 24 such that R prime of t equals 0? All right, we'll go back up here and look at your table. Okay, we're talking about 0 and 24. So R of 0 is 11.6. R of 24 is 11.6. So if f of A equals f of B, we do know that R of t, since R of t is differentiable, therefore it is continuous. So they did tell us, just real quick, they didn't tell us in the problem that it was a differentiable function. Remember, if it's differentiable, then it is continuous. And we saw that R of 0 equals R of 24. Then we know that Rolle's theorem guarantees a value of t on our interval 0, 24 such that R prime of t would equal 0. Did not say find that, it just said justify, and we're justifying it using Rolle's because our two ends are equal. All right, so that takes care of the T2L2 notes we did not finish in class on Friday. And then there will be a second video added for the T2L3 notes that you will use for your remote learning day tomorrow. Okay. All right. Y'all stay safe, and I will see you when we return. Make sure you do fill in the notes for tomorrow.